Lesson 83 is about coin problems, and as you can see in this practice problem, these are word problems. And we've been doing some problems with simultaneous equations, solving systems of simultaneous equations. And those have been two equations of lines, and when we solve those, we're solving for where those lines intersect, and we get a pair of values as our answers. Now we've also been doing some simultaneous equation problems where we had subscripted variables, and we used substitution or elimination to solve those. They're just like linear equations because they just have two unknowns that are first degree unknowns. Now when you do these word problems, these coin word problems, you'll be trying to figure out two equations, two linear equations that you can solve simultaneously to figure out your unknown values. And so you're familiar with what those two equations will look like. Now you just have to make the equations and then solve them. Before you were already given the equations. Now you have to make them based on what the word problem says. Then you solve the problem. So look at practice problem A and let's read that through. It says Luke and Michael have 17 coins that are nickels and dimes. If the value of the coins is $1.25, how many coins of each type do they have? Now in a word problem, you're always trying to figure out what is the question they're asking. What am I supposed to be solving for here? The question is how many coins of each type do they have? Well, they have nickels and dimes here, so those are our two unknown values. And remember in lesson 79 when we talked about systems of equations with subscripted variables, and we said if you had four unknowns, you had to have four equations to solve that system. You always have to have the same number of equations as you do unknown values. So right here we say how many coins of each type. There's two types, so that means we need two equations. Set up two equations and we can solve those simultaneously, and we'll be able to figure out our nickels and dimes. So let's think of a couple of equations based on what the words say here. Let's just go back through and read the first sentence. Luke and Michael have 17 coins that are nickels and dimes. So that means that the number of nickels and the number of dimes total up to 17. So there's an equation. And we can just say N for nickels plus D for dimes equals 17. Now in the book they use subscripted variables, but I think it's easier just to do it like this without the subscripts. It's just less stuff to write basically. Subscripted variables, what you're trying to do there is just describe a quantity from a word problem, and you don't have to have a subscript to do that. It just has to be something that makes sense to you. And to me, N for nickels and D for dimes makes sense. I can remember which is which. Now if I were using X for nickels and Y for dimes, that would be a little more confusing because I might forget which one I was talking about for Y. So now we have one equation, but it has two unknown values in it, so we need one more equation here. And let's read the second sentence. If the value of the coins is $1.25. So there's the value of the coins. The total value of the nickels and the dimes will equal $1.25. So let's just put, at least we know this, equals 1.25. Now here comes the sort of tricky part. You've got to think about how much a nickel costs and how much a dime costs. Well, a nickel is 5 cents, right? So each nickel, if we had two nickels, that would be 10 cents. So we would have to, if we were trying to figure out the value of all of our nickels, we'd put a 5 in front of that number of nickels. And then the dimes, we'd put a 10 in front of the number of dimes. And because each dime is 10 cents. Now on the right, I have that in dollars. We need to change that and just take the decimal place out. And so we have that in terms of cents. Everything has to be in terms of cents. 5 cents per nickel, 10 cents per dime equals 125 cents. So in other words, all of our units have to be the same in the problem. We can't have cents for nickels and cents for dimes and then dollars on the right side. Everything has to be in terms of cents, or we could have done it all in terms of dollars. It's just easier not to have a decimal point to mess with. Okay, so now we have two equations and two unknowns, and hopefully you can recognize that those look like linear equations, so we can solve them simultaneously and we'll be able to figure out our nickels and dimes. Let's just take the top equation, solve it for n, and substitute it into the bottom equation. We could use elimination to solve this as well. It doesn't matter. We could use substitution or elimination. But I'm going to use substitution. So I'll say n is equal to 17 minus d. Just move the d over to the right, and now we'll substitute that in to the second equation. So we'll have 5 parentheses 17 minus d plus 10d is equal to 125 cents. Now we'll go ahead and expand out on the left. 5 times 17 is 85. And then 5 times a negative d would just be negative 5d plus 10d is equal to 125. We'll go ahead and add those like terms on the left. That would equal up to 5d. Subtract 85 from both sides. Whoop. And so we'd end up with 5d is equal to 40. And I kind of wrote that equation at a strange angle there, but it's 5d equals 40. So that means the dimes equals 8. And so if we substitute that back in to n equals 17 minus d, we'll have 17 minus 8, and that equals 9. So there's our number of nickels, is 9. So there's the answer to that problem. When we have 17 coins that are nickels and dimes and their total is $1.25, there's only one combination of nickels and dimes that'll work. And so it's just like an intersection point on a pair of lines. There's only one point that they intersect at. So there's only one combination of nickels and dimes that will work for this combination of coins and money value. And that is 8 dimes and 9 nickels. Let's try another problem. Let's read this one through. Ellie has $3.70 in quarters and dimes. She has 2 more dimes than quarters. How many coins of each type does she have? So these coin problems are usually pretty easy to recognize because they always ask us how many coins of each type do they have. And so we have 2 unknowns there that we're trying to figure out. And so we just go back through and we look and see what our values are and what are 2 equations that we could set up based on the values they've given us. Well, first it says that Ellie has $3.70 in quarters and dimes. So let's go ahead and set up an equation based on the value there. So we're dealing with quarters and dimes, and a quarter is worth 25 cents. So we can say 25 Q for quarters. And if that's confusing, just think about it. If you had 3 quarters and you want to know what their value was, you would take that number of quarters and multiply it by 25. That's what we're doing here. The Q stands for the number of quarters. The 25 stands for how much each one costs. So 25Q, and then dimes, so we'll say plus 10D. That value totals up to $3.70 or 370 cents. So we want to put everything in terms of cents so that we have all the same units. Now we need one more equation, and let's just read that second sentence. She has 2 more dimes than quarters. Now let's just think about that. The dimes is equal to Q plus 2. There are 2 more dimes than quarters. That would be the right way to write that problem down. D equals Q plus 2. And you can think about it. If she had 5 quarters, then she'd have 5 plus 2 is 7 dimes. She'd have 2 more dimes than quarters. That one can be a little bit tricky setting that equation up, because sometimes you might think, well, she has 2 more dimes, and so you think, well, 2 more than is 2 plus 2 more dimes than quarters. But it's really not that way. You have to make sure and substitute a value in to make sure that's working correctly. Like if we said 2 plus D equals Q, we'd say, well, if she had 10 dimes, she would have 12 quarters. But that's not right. She'd have more quarters than dimes then. So that's not the correct way. So to set that one up, you might just write down both ways to do it. D equals Q plus 2 and 2D equals 2 plus D equals Q. And just substitute in if you're confused about which one is the right one. Once you substitute a number in, it's real easy to tell if you've got your equation written correctly. Okay, so now we have two equations and two unknowns. This looks like a problem that would be easy to do substitution on, so we'll substitute that second equation into the first one. And so we'll have 25Q plus 10 times Q plus 2, and that equals 370. And then we'll expand this out. 25Q plus 10 times Q is 10Q, and then plus 10 times 2 is 20, equals 370. Okay, so then let's go ahead and subtract 20 from both sides there, and then we'll add 25 and 10Q, so that would give us 35Q is equal to 350. Divide both sides by 35, and Q would equal 10. Okay, so then we can substitute that back into our second equation. D equals 10 plus 2, and so that is equal to 12. So our dimes, we have 12 dimes. And so that's the combination of quarters and dimes. There's one and only one combination of quarters and dimes that would satisfy this word problem, and that's what it is there. That would total up to $3.70, and there end up being two more dimes than quarters, 12 dimes and 10 quarters. So hopefully you're starting to recognize here on these coin problems, you'll always have two equations because you'll have two unknowns. I mean, eventually, probably in Algebra 2, you'll have problems like this where you have three different coins in the problem, so you'll have three equations that you have to develop. But for right now, we're just doing two unknowns, so we'll just have two equations. One of them deals with the value. The other one deals with the quantity of coins. And that's always how they will be. One equation based on value, one based on quantity. Let's do one more problem. On this one, you should pause the CD and see if you can figure it out on your own, and then fast forward to the answer and see if you got it right. It says there were 38 nickels and dimes in the tray. If the value of the coins was $3, how many coins of each type were there? So we see it's a coin problem. We see that we want to know how many coins of each type there were. So that means we need two equations because we have two unknowns. So let's go ahead and set up our value equation and our quantity equation. The first sentence says there were 38 nickels and dimes in the tray. So that means our total of nickels plus dimes equals 38. So there's one equation. And then the second sentence says that their value was $3. So a nickel is 5 cents. So we say 5N. A dime is 10 cents. So we'll say 10D equals 300 cents. Remember, that's real important. Everything needs to be in terms of cents. Now, let's go ahead and use elimination this time to solve this system of equations. We could use substitution, but it doesn't really matter. Either way, as long as we get the right answer. I'm going to multiply everything by a -5, and that'll get rid of all of the n's. And so if I multiply everything in that top equation by -5, I'll just rewrite that equation down here. Minus 5n minus 5d is equal to 190. Actually, -190, right? So now the 5n's cancel, and then I have 5d is equal to 110. If I divide both sides by 5, the number of dimes is equal to 22. Okay, so now I know how many dimes I have. I can substitute that back. I'll substitute it into the top equation, and I'll see n plus 22 equals 38. subtract 22 from both sides, and the number of nickels is 16. So I have 22 dimes and 16 nickels for a total of 38 coins, and that combination there of 38 nickels and dimes equals $3. There's one and only one combination of 38 nickels and dimes that would equal $3, and that's what it is. 22 dimes and 16 nickels. So on these coin problems, you set up a value equation and a quantity equation. You can solve them either using substitution or elimination. It does not matter. What matters is that you get the right answer. And don't forget on that value problem, when you set that value equation up, that you make everything in terms of cents. Or you could make it all in terms of dollars. It's just usually easier to work with cents because you don't have a decimal place to deal with. Okay, well that's all for lesson 83.